And this session we're going to do solid edge surfacing part 2. I believe part 1 was just because of the schedules and the layout was a couple of weeks ago. You can find that out on the CamLogic channel out on YouTube. Speaking of CamLogic, just a quick overview of who we are and what we do. We were founded in 1995 by Kit Carlisle out of Oxford, Michigan, and we are a complete end-to-end engineering hardware and software resource for companies in Ohio, Indiana, Pennsylvania, and Michigan. So of everything that we do, we can best divide it out into 3 different areas. Again, 3D scanning, 3D prototyping, and CAD. In the CAD world, we are Siemens certified solid edge partners, so we do NX, solid edge, PMAP, Team Center, all of the things that the Siemens PLM division brings to the table. We proudly support and carry those as well. And then also Esprit on the CAM side as well. On the 3D printing side, we are a Z Corporation provider and supplier. Z Corp, I say this every time, but it's an amazing thing. Take that 3D CAD model, drop it into the machine, print it out, pull it out, hold that model in your hand. It's colored. It's in some cases it's flexible. It's ready to go. It's ready to present. And then on the 3D scanning side, we have roller arms and also some shape grabbers and things like that. Basically, what this allows us to do is to go out and to laser scan a part. And then you can do 2 things with it. You can use those parts, those points, to rebuild the CAD model. Let's say you have an older piece. You don't want to measure everything. You scan it. You can rebuild the CAD model. Or number 2, you can take the model that's coming off of the out of the machine or down the line. You can take that out, scan it, make sure it's within specs. So this week we're going to talk about solid edge surfacing, and again this is part 2. Just in general, just so you know, solid edge surfacing is best used sketch based, so you're drawing profiles as to what you want. Free-form modeling. If you're going out there and you say, I need something that looks kind of, sort of, something like this, well, that's a good time to use surfacing. Also non-planar, non-analytical. When you want to go out there and say, I've got this piece and it's going to twist and it's going to curve halfway around and then go straight and then go to a point, things like that. It is a great way, it's a great time to use surfacing. And then also to repair and enhance imported models. Last time we talked about this, and this again is out on YouTube. We did a basic swept surface, cross curve, revolve as a reference. We did a tire. We were making a fender. So in order to see what size of fender I needed, I used surfacing to make a tire very quickly, just so we could work around that. Free form, and then replace face. On this session, we're going to go ahead and look at blue surf, bounded surface, wrap sketch, and project to sketch, or project sketch. So let's go ahead and start with our project sketch. I'm out of my solid edge part, and I've got a fairly complex shape that I created, and it started from this straight sketch, went to the curve sketch, and then went to this free-form curve, if you will. Actually went to this free-form curve, and I used blue surf to tie that all the way in there. You can see that blue surf went across there. Then I used a thing called thicken, and we'll see this later on. But I used a tool called thicken that allowed me to take that complex shape and give it an actual thickness, and then it become a part. So today what we're going to do is we're going to learn about projected sketch. So I want to take this projected sketch, and this sketch right out here is nothing more than some text. We'll come over here. This projected sketch is nothing more than a set of text called projected sketch. You can have anything that you like, but it's setting out on a plane, on a regular flat plane. And I want to go ahead and use surfacing now to project that sketch. So the first thing I want to do is pick on the entire sketch there. I might just do it single. Bear with me 2 seconds here. So we'll go ahead and project that sketch. And just take it right like that. And I'm going to take out that line. I don't need that. And then I'm going to pick on the face that we're going to project to. And now I'm going to tell it to project down. So now I've got projected sketch. This, almost as if you will, this was on this sketch. The text right out here was on a piece of glass. And if you think about it, we shot a spotlight through there, and that shadow of that sketch went right down onto there. So we have our projected sketch, and in this case, we'll go out and we'll add a normal to this normal protrusion, if you will, to this. Go in and then come up. In this case, we went up 20 thousandths. Okay. So I've got a projected, roll over this way. I've got a projected sketch that I came from up top of a flat plane, shot it down, and projected it on there, and then now I can go ahead and bring that up. And that can be with text, that can be with bosses or bumps or holes or any offset that you want, or even cuts. Cuts can go through there and do the same thing. So that was a projected sketch. Now I want to go over to a wrapped sketch. A wrapped sketch is just basically, think of a label. And as the part says, this text can extend past the normal surface of the part. So we're just laying this out, and this is, you know, think of a piece of tape, think of a label that we would peel off and stick. And we'll just simply go to our surfacing at this point, and we'll just go ahead and wrap this sketch. And I'm going to take just this face right here, and then take and finish that. Okay? So now, again, we can cut, we can do anything that we like. I want to take that off, and you can see that it's just like a piece of tape. And you can see that this text does extend past the normal surface of that part. So I can just make that label as big as I like, small as I like, and I'm just laying that around there. In this case, we would make the part wider, you know, to accommodate that whole label, if you will. But that is a wrap sketch. A wrap sketch is basically, if you think of a sticker or something like that, where you're taking a specified piece and wrapping it around the surface. And again, it can be bigger than the surface. It can do whatever we need it to be. But we're just laying, if you think of a label or a sticker, that's what a wrap sketch is. So let's switch over to a bounded surface. Now, a bounded surface allows me to repair things that are missing. In this example, I'm going to go over and I'm going to go to my surface and I'm going to copy a surface. Now, there are things when I copy a surface inside of surfacing, I can have the ability to remove internal boundaries. So let's say if I were to click on here and remove internal boundaries, it would automatically plug those holes. Die makers and tooling makers, you understand the power of that, is because I want to make a tool that fits the surface of that, not necessarily, fills in through the holes. So to copy a surface is a very strong tool, but what I'm going to do in this case is I'm going to not to hide or not to fill in those internal boundaries. I'm just going to keep the internal boundaries that I have. So for instance, I may want to make tooling that fills in everything but this one hole right here. So I'm going to go to bounded surface, and this is the same in repairing something. If you've got a bunch of sheets that are coming together and there's an extra tier or pear shape that is missing right there, as long as that's closed in, I can go to bounded surface and just click and bound over that surface. I'll do it again. I'll take this one, and it's enclosed. Right click to accept, to preview, and then I can bound over that surface. So in other words, I'm taking all of this surface. I didn't want to close in all of the holes, so I chose not to close in those holes, but I have bounded in the surfaces that I want. Now, in this case, I can also go ahead and stitch the surfaces. So I can take these are now multiple surfaces, these three, and it will actually stitch that together as one unit. Okay, those are my choices, and that's bounded surface. Now, I want to switch over to probably the cool portion of this presentation, and that is a little bit of blue surf. And we'll even do some photo rendering at the end too, because I think this is cool. This is a light post that sits on top of a post, and it's a cap. We've got some screws over here. You can tell what kind of project I was thinking of when I wanted to build something like this. So this just sits on top of a post, and here's the light and a light bulb, but we want to go make a shade for that. So I want to start over and start working in this part. Now, just for the sake of time, I've gone ahead and I've inserted that light unit as an inner part copy, and I've also started one sketch down there at the bottom. Now, as we said, surfacing is sketch based, so I'm going to start a new sketch out here. And I'm just going to tip, and what I want is to include these edges. So in other words, I'm choosing a start and a stop point for my lens. So here would be my starting point. Here would be my stopping point up top where I wanted to match through. Now the next thing I'm going to do is I'm going to make a sketch out on a parallel plane. And we'll come around here. Just set this around. Now we'll come around here to the middle point of this opening. Now, at this point, I don't really need to see I don't need to see anything else at this point, because what I want to do here is I want to go and create an arc by 3 points. And then really all I want to do is just say, yeah, we know the lens has to end back there, but we want to add a little bit of artistic flair to the part. So we want it to come square down at the bottom, round at the top, and then in the middle we want it to come out a little bit. So we want to get fancy, as it were, when we do this. Now, to that, I'm going to add another sketch on a parallel plane. And I'm going to come from here, and I'll take it to the midpoint. Now, to there, what I'd like to do is I'm going to go ahead and create a curve. And a curve is you can think of it any way that you like. I like to think of it as a rubber band. You can stretch it, you can move it, you can do anything you like to it. One of the nice things about this curve is that it does have specified points. So I can take these 2 points and I can make sure that the inside curve is going to be the same on both. So even though it's a freehand, free form type thing, I can add constraints, and I can also dimension as well. But I can add constraints, and I can work with that. So I have this. I really don't need anything else at this point to start my work. I don't need any other part. So I'm going to start with blue surf. Now, blue surf is much like taking saran wrap, cellophane, if you will, and just stretching it over certain areas. So I'm going to take and go from one area to another, and Solid Edge is just going to shoot this very, very fine, very, very thin piece of material, surface, right over there. So I've got my part, but what I want to do is right now it's going from cross-section to cross-section to cross-section. And that's fine, but what I want to do is I want to insert a guide curve. And I want to follow that guide curve. And if you'll see that, it'll actually bow in and follow this guide curve now. So it is going from part to, or cross-section to cross-section to cross-section, but it is also following this curve that I have set up over here. So have something like that. I'll go out and I will add and I will thicken, and I've already set this to a certain thickness, and I'm going to make this, and I've already given it a material just for the sake of time, and this piece is glass. So again, this is going to be used out in my light box. So you can see that I have my bulb, I have my light shade there coming out very, very nice. Now, what's one of the nice things about this, we'll just finish this off just because it's just such a nice little piece that we worked with. I'm going to go out to my ERA, and I've already done this, but we'll go ahead and just run the scene and just let you see what this part can actually look like now that we run with this. So if you're doing customer parts, if you're doing consumer parts, things that that the looks are important, don't be afraid to use surface. Don't be afraid to make that a better model than the next guy is making. Don't be afraid to say, I want this part to go from here to here to here, from cross-section to cross-section to cross-section. Don't be afraid for it to do that. And then when you have that, you can have a much better looking part than you would than, say, the next guy that just makes it flat or straight or round. So again, the surfacing is a full complement of tools The surfacing is a full complement of tools. We also teach the classes swept, bounded, extrude, revolve, offset, copy, glue, dot, trim, extend, split, stitch, replace. Under all of those, we've got some other things, other tools under those. So it is a full complement of tools. So today, very quickly, we looked at blue surf, bounded surf, wrap sketch, and project sketch. Again, all of this stuff, all of this that we talk about does come in our training. We're more than happy to walk you through anything that we show here, and a lot of things that we just don't have time to show, but we are willing to teach you as well. These sessions can be found on YouTube on the CamLogic channel. They are posted within 24 hours of this meeting, so you feel free to review those at any time that you like, pass them around. Again, my name is Dewiel. Feel free to give me a call. The number is 248-969-9201. Drop me a line at dald@camlogic.com. More than happy to talk with you about any of your training needs, any of your engineering needs, hardware or software. Well, I do thank you for your time, and we will see you again as far as Solid Edge in a few weeks. But stay tuned, because next week there will be more Tech Tuesdays on different different products that we support as well. Well, thank you for your time, and we appreciate your attendance.
The